Students, we are going to have video which is indicating density, vapor density, relationship, and stoichiometric problem. Density, all of you know, is simply mass per unit volume. For example, gram per cc, gram per milliliter, kilogram per cubic meter. What is vapor density? Vapor density is defined as the ratio between mass of certain volume of gas over mass of same volume of hydrogen under similar condition of temperature and pressure. Under similar condition of temperature and pressure. This is the ratio between the two. Now, if the condition, if the volume is taken as, let us take this volume as is 22.4 liter and temperature is 0 degrees Celsius and pressure is say 1 atmosphere, then this mass will be mass of 1 mole of gas over mass of 1 mole of hydrogen at STP, because at STP temperature is 0 degrees Celsius and volume is 22.4 liter for 1 mole and pressure is 1 atmosphere. So this is 1 mole. This is from mole concept. From where we are getting it? From mole concept. And then this is the, what they call it, volume part of mole concept. That 1 mole of gases at STP occupies a volume of 22.4 liter. Secondly, why certain volumes, same volume are having same number of molecules? This is as per Avogadro law. This is proportional. V is directly proportional to N under similar condition of temperature and pressure. This is Avogadro law. So we are having 3 gas laws: Boyle's law, Charles law, and then we have got this Avogadro law. And here mass of 1 mole, this is mass of 1 mole of this and mass of 1 mole of this. Now here, this is known as, whatever is mass of 1 mole of this, that will be known as molecular mass of gas. And here it is molecular mass of hydrogen. So therefore, vapor density will be simply molecular mass multiplied by 2, because hydrogen the molecular mass करना है, that is 2. So here in this relationship we are using what they call it mole concept. One part, that is 1 mole of all gases having same volume under similar condition of temperature and pressure. Second, we are using Avogadro law. In that case, volume is directly proportional to number of moles. So naturally in this case, ultimately, again here we are having this is possible only under similar condition of temperature and pressure. So as a result of that, vapor density is equal to molecular mass into 2. So what are the units of this? Now molecular mass of gas will be given in say U. Here it is also given in U. So naturally this has got no unit. Vapor density has got no unit, while density is having unit of mass per unit volume. So vapor density of substance, gaseous substance, is having no units. It is simply what they call it. It is So this is, here we are having this will be something here. So in this case, it will be molar mass will be equal to vapor density into 2. So as a result of that, this is the relationship. Now what is the relationship between density and vapor density? What is the relationship between density and vapor density? Now we are having, this is gas loss, Boyle's law, volume is inversely proportional to pressure at constant temperature. Then Charles law, volume is directly proportional to temperature at constant pressure. And we are having this Avogadro law at constant temperature and pressure. Combining all of them, you are getting PV is equal to nRT. We are getting this gas equation. What is N? N is number of moles, P is pressure, V is volume, R is gas constant, T is temperature. So as a result of that, what we are having, this is the gas equation. Now here in this case, this is N is equal to, what is the number of moles? This is the mass of substance, mass of gaseous substance over molar mass. Let us say M dash is molar mass of gas. M is molar mass of gas. So as a result of that, what will happen? Okay, number of moles will be equal to, here you are having P, this is M upon V, RT upon M dash. So from here you will be having this M dash upon this. This is something what we have got. This M over V is density. M over V is density. So therefore the formula will become P is equal to dRT upon M dash. So this is the relationship between, this is M dash is molar mass, so M dash will be equal to dRT upon P. So M dash is equal to, we have already seen, this was equal to twice of vapor density. So therefore the vapor density into 2 is equal to dRT upon P. So this is the relationship between that. The relationship between vapor density and density is given by this equation that is based on the gas laws. From here it becomes clear, vapor density is not changing with temperature and pressure, while density will be changing with temperature and pressure. So as a result of that, what we are having, because molecular mass is constant, therefore vapor density is also constant, while density is changing with temperature and pressure. So density will be changing with temperature and pressure. Secondly, density is having units, while vapor density is not having units. So that was the vapor density and density. Now the second thing, we are having this problem. So this was the density, vapor density and their relationship. Now next thing is a problem based on stoichiometry. So here we are having a problem. For example, the problem is that you are having certain weight of KClO3, upon heating loses 0.49 gram of weight. This is losing 0.4 gram of weight. So weight of this is given by 0.34 gram. So this is losing this is 4.9 gram of this is losing 4.9 gram of this is losing here it is 0.348 gram of weight. So this is 4.9 gram of KClO3 upon heating strongly losing this much weight, 0.384 gram of mass. If the sample is free of vaporizable impurities, then the percentage purity of KClO3 will be given by. What will be the percentage purity of the KClO3 sample? Now here the reaction is KClO3 upon heating give you KCl, this. So it means why it is losing weight? Because of the loss of oxygen. So here molecular mass is 122, 39 plus 35. This is 74.5 and 40. 122.5 is the molecular mass of this. This is equal to what they call it 32, and here we have got this is multiplied by 2 because 2 moles are taken, so 1.22.5 is 245 gram. Here it is 32, 96 grams. So it means here if it is 242 moles are giving you 3 moles, so 245 gram is giving you 96. 245 gram giving you of KClO3 is giving you 96 grams of oxygen upon heating. So 100 will be giving us, this is 96 divided by 2 into 100, that should be 39.8. So that is the percentage. If KClO3 is 100% pure, then it is having, this is if KClO3 is pure 100%, so it will be losing 39.8% weight. It will be losing 39.8% weight. So naturally here what is the situation? In this case we are having sample is 4.9 gram of KClO3 upon heating losing 0.384 gram of weight. So this is losing this much weight. So if it is this, so it will be 0.34 gram divided by 4 point, and it is 100. So out of 100, it will be losing 0. into 100. So this will be the situation. So here it should be, it turns out to be approximately 7.8. So it means that if it was 100% pure, then it should be losing this. If it is this, so it means it is impure. So what is the percentage purity of sample? Percentage purity of sample KClO3 will be 7.8 divided by 39.18 multiplied by 100. So this is giving you percentage purity of this sample. So always remember, whenever you have to solve this problem, we should be first of all knowing the chemical equation. For example, potassium chlorate upon heating is giving you this. So here it is 122.5 is the molecular mass, 2 moles means 245. Here it is oxygen is 32, 3 moles means 96. So here it is giving you 245 is giving you 92, 100 will be giving you this much 39%. So naturally, had it been 100% pure, then it should have been giving you 39%, 39.18% of oxygen. But here the situation is that 4.9 is giving you only 0.384 gram. So what is the percentage turning out to be? 7.8. So इसका मतलब sample is giving you lesser amount of oxygen. So that means that here sample is impure. And what is the percentage purity? The This is the amount given over the expected amount multiplied by 100. So that will be giving you the percentage purity. So always remember, whenever you are to solve such problem, first of all, one should know the equation. Then just see, here it is 2 moles, 3 moles. So it should be balanced equation. If we write simply 1 KClO3, 1 KCl, it should be 1.5 here. So naturally we should solve it accordingly. So if equation is wrong, you won't be able to solve the numericals. Here in this case, only weights are related. So here mass relationship. Then according to mole concept, the mole is a quantity of substance which is having some Avogadro number of particles. It is weighing equal to, it is gram molecular mass or gram atomic mass. Thirdly, if it is gaseous, so it will be occupying volume of 22.4 liter at STP. So naturally, mole concept has got 3 parts. So naturally, problem based on this chemical equations or stoichiometric problems will be also of 3 types. Rather, first of all, mass. Then second is mass, volume. Third is volume and volume. And fourth is, this is the main problem. Then you can also add up something more. That is the number of molecules, because the mole concept has 3 parts: number part, volume part, and what they call it, mass part. So here it is mass, volume, volume. So we can also be asked to calculate the number of molecules of oxygen formed. So naturally 3 moles. So how many molecules of oxygen are formed? It is 3 into Avogadro number if it is having 245 grams. So naturally you can be asked to solve number of particles, you may be asked to solve weight, you may be asked to find out volume. But whenever you are dealing with volume, whenever volume comes for gaseous substance, so naturally here you have to specify the temperature and pressure, because the volume of gases is affected by temperature and pressure, while temperature and pressure are not having that much effect in the case of solid and liquids. So here in the case of gases, for example, in this case we have invoked this relationship for gases. So therefore, in order to understand all this, mole concept should be clear. Then one should be having the knowledge of the, what they call it, gas laws. Mole concept, gas laws, then the balanced chemical equation. Balanced chemical equation means one should know why it is KClO3, because potassium and ClO3 are monovalent. Potassium and chloride are monovalent. So one should know it. If one is not knowing it, then you cannot solve such problem. So that's all for today. We'll be continuing with this next time. Thank you very much. Wish you all the best. What's the secret of success? Only self-study. Nothing else is as essential as self-study, because your own efforts can help you, and ultimately whatever problem you have been coming across, you are most welcome to ask it to me. You have sent it to me, and I have already given my number to most of you. It is 94634777804. So this is my telephone number, so you can contact me. Thank you very much.